NASA's OSIRIS-REx spacecraft is equipped with a suite of instruments designed to study its target, a near-Earth asteroid called Bennu. One such instrument is called REXIS, the Regolith X-Ray Imaging Spectrometer. That complex name matches its complex task.
REXIS is something completely different than the rest of the instruments aboard OSIRIS-REx. And that's because REXIS will detect elements, the individual atomic elements that make up this asteroid. Everything else is mapping the geology or the interior or even the mineral structure. And we are at the most fundamental level looking at what this asteroid is made out of.
REXIS works off of how the sun's X-ray light interacts with the surface material covering Bennu. Atoms on the asteroid absorb these X-rays, causing their electron levels to temporarily change and emit their own X-rays. These re-emitted X-rays have a specific energy that tells us about the atom that they came from. This process is called fluorescence, but you can think of it like a glow. REXIS is a telescope that images that X-ray glow, which allows scientists to create a map of the different elements present on Bennu's surface. And REXIS has the ability to do all this based on its design and its position on the spacecraft.
REXIS is about the size of a shoebox. It's located on the main instrument deck of the OSIRIS-REx spacecraft. Basically, this is the side that's always facing the asteroid.
The pieces of the REXIS instrument are composed of two primary parts. We have the main REXIS telescope, which views the asteroid Bennu. It's consisting of 4 CCDs that look through a coated aperture mask. The coated aperture mask is just a stainless steel plate with a number of holes that are known to us. The second part of the X-ray instrument is called the Solar X-ray Monitor, or the SXM. The SXM is viewing the sun at all times so that we can monitor the X-ray spectrum, the solar X-ray spectrum, incident on the surface of the asteroid.
The Solar X-ray Monitor lets us calibrate out the day-to-day, even the hour-to-hour variations in the X-ray flux that comes from the sun.
So like your digital camera or camera phone, the main spectrometer uses a light sensor, known as a CCD, or charge-coupled device. In this case, there are 4 of them, and they're only sensitive to X-ray light. Before the X-ray photons from Bennu are detected by the CCDs, however, they pass through a mask with a random pattern of open and closed holes. By analyzing how the shadow of the mask pattern is shifted on the CCDs, scientists can determine the location of the X-rays coming from the asteroid's surface. This is how REXIS images Bennu. And one surprising aspect of the REXIS instrument is the team that built it, students from MIT and Harvard.
The students are fantastic to work with. They're so eager to learn. It's been great sort of watching them as they grow in this experience. And I think they've come with some interesting ideas and some ways of looking at it that we may not have had had we been someone who's been doing this for years and years and years.
Other missions have had X-ray spectrometers on board, but not nearly the level of sensitivity and sophistication of REXIS. This really is a new generation, a next generation in X-ray imaging for planetary science, and it's all being done by students.